between 2 points, and instantaneous is what the tables approach. So now we can officially say that the derivative is the instantaneous rate of change. When you made those huge tables to get to everything, that is just the derivative value. And now we're figuring out how to do that without going to all the trouble of making tables. First, I just want to talk a little bit about the meaning of these. This seems to be something that sometimes people struggle with a little bit. So, this example, a manufacturer produces bolts of a fabric with a fixed width. The cost of producing X yards of this fabric is C equals F of X dollars. Part A, what's the meaning of the derivative F prime of X? So, a derivative is a rate of change. Think Y over X. Y was the dollars, X was the yards. So this is the rate of change in production. It's telling me how it's changing. So the units, Y over X, would be dollars per yard. So it's basically saying, you know, if I add another yard, how much more is it going to cost me to do that? How is my cost changing? All right. So next, in practical terms, what does it mean to say that F prime of 1,000 equals none? So the X is 1,000. So it's saying when 1,000 X was yards, so when we produce 1,000 yards of fabric, we already said up here the derivative was the rate of change in production. So this is saying the cost is increasing. Why do I know it's increasing?
Positive.
Because it's positive. So it's increasing $50 per yard. Okay. Not 50. Where did I get 50 from? Oh, I looked down below.
Yeah,
Sorry,
sorry.
$9 per yard. Were you guys completely confused for a second? So does this tell me that if I make 1,001 yards of fabric, it will cost me $9? No. What it means is if I make 1,001 yards, I will have to pay an additional $9. I don't know what the true cost is, I just know how much it will go up if I add more. Okay, so if I added 2 more yards, I would guess that my cost would go up by $18. Okay, it's $9 every yard. So part C. Okay, my touch isn't working on my board today. It's really frustrating. What do you think is greater? F prime of 50 or F prime of 500? So think about what this means. F prime of 50 is if you produce 50 yards of fabric, how much more would I pay to make an additional yard? If I produce 500, how much more would I pay to make an additional yard? In general, the more you make, does it cost more or less per item? So same in a sense. Think about if I have, alright, let's take the Lotus drink business, okay? So some of their costs are fixed. You know, they got their trailer, they got their equipment, and they've got that stuff. And so like the cost to make the drink is the same each time. But if they only sell 50 drinks, they have to take all of their costs for the equipment and everything and divide that up over the 50 drinks. But if you sell 500, you can take those costs and split it 500 ways. So which way are you paying more per item? Yeah, the smaller amount you're paying more per item because you have to divide up those initial costs over a smaller amount. Okay, so we would expect the f prime of 50 to be more than the f prime of 500 because you have some costs that you have to pay no matter what, and the more you can divide them up over, the lower that cost goes. Now, what about if they start selling 5,000 drinks a day? Are they going to be able to do that with their current setup? Probably not. So don't you hit a point where it's not going to be cheaper? You know, we're going to hit a point where this is all the drinks they can produce in a day. And so if they want to produce more than that, they're going to have to get more workers and bigger equipment and a bigger space and all of these things. So it's not an infinite amount. You can only have your maximum production and then you have to upgrade everything to keep producing more. So the 5,000 may or may not. So I'm just going to say f prime of 5,000 may be more costly if production becomes inefficient. So if they're going to have to make some major modifications in order to meet that demand, then it may not necessarily be cheaper per item at that point. Does that make sense to everybody? Okay. All right. Let's look at a question. You guys might want, here, instead of giving you a ruler, use your other sheet of paper to kind of draw some lines here on this. So we are going to put these numbers in increasing order, so small to large. Okay, 0 is pretty obvious. 0 is 0. G prime of -2, that's saying when x is -2, the derivative is the instantaneous rate of change. It is the slope of the tangent line. So this is highly inefficient because my board doesn't work and I can't write on it. But if you were to take your paper and kind of use that line to draw a tangent line there, just as best we can. Let's see, so it would look roughly like this. The tangent line kind of hits it once and bounces off. It's following the general shape of our graph. Okay, so G prime of 0. That one would look something like this. G prime of 2, something like that. G prime of 4. Okay. So first of all, if we're going small to large, any negative numbers would come first. Would any of these derivatives be negative? Any of those lines you just drew, do any of them have a negative slope? G prime of 0 has a negative slope. So it has to be my smallest one. So that means after that we would have 0. Okay, these derivatives represent slope. So the other three all have a positive slope. Which one would be the smallest? So the smallest slope is like the flattest line because slope measures the steepness. So the flattest line here would be at 4. Okay, -2 and 2, it's a little bit harder to tell. Basically want the least steep of those, so it's kind of a toss-up. I might say that at -2 it's a little bit less steep, and at +2 is probably my steepest line. So that's an approximation. We didn't really find that for sure, but just a rough guess based on our slopes. All right. Is that okay with everybody? rest of these examples, they're all pretty much, you have a homework problem almost identical to each of these. So like, I think I assigned problem 13, and I think I'm doing problem 14 here. So pretty much all of these, I'm just doing something exactly like in the questions on the homework. So if a rock is thrown upward on the planet Mars with a velocity of 10 meters per second, its height after t seconds is given by this equation. Part A. Find the velocity of the rock after 1 second. Okay. Average velocity is just a slope. Instantaneous velocity, or velocity at one particular point, is a derivative, which is what we were doing on Friday. So when we did derivatives, we said there were two forms we could use. We preferred to use the limit as h approaches 0 of f of a plus h. So that means if you plug in a plus h in for all of your t's in this case, minus f of a, so you just plug in an a, all over h. Alright. So in this section, we really just end up doing a lot of algebra. If I multiply this out, get 10a plus 10h. What would I get if I took a plus h and squared that? If you wrote it twice in FOIL, what does that give you? Right. A squared plus AH and plus AH, so you can make it 2AH plus H squared. Are you guys okay if I just write this above and save myself a line? So now if I distribute a negative 1.86 through this, I get negative 1.86a squared minus 3.72ah minus 1.86h squared. All of this came from that first bit. What do I need to do with this second one? So minus 10a plus 1.86a squared. Alright. So now, 10a and negative 10a cancel. Negative 1.86a squared and positive 1.86a squared cancel. So everything that's left what could you do? And then if you plug in 0 for your h, you get 10 minus 3.72a. Okay. Now this is actually the answer to part B. In part B, I just asked for the velocity when 10 equals a, and I did that on part A so I wouldn't have to recalculate everything. Part A wanted the velocity at 1 second, so what's my A? I'm telling you, A is 1. So if you plug in a 1, you get 6.28. Velocity would be meters per second. So part A was asking at a particular point. Again, you could have plugged in the 1 at the very beginning, but I knew in part B I was going to ask you for the formula, so I just did it. with the a, and then you can plug in any time that I might give. Part C, when will the rock hit the surface? Alright, so that means what's 0 if it hits? The height is 0 if it hits the surface, right? So we have to go back to the very beginning, and our height is 0. So I could pull out a t. So you get t equals 0, 4. Get 5.38 seconds. So that's how long it takes to hit the surface. So the height is 0. Then I ask, what's the velocity when it hits the surface? So I know my time, so then I can use my velocity formula, the 10 minus 3.72a, and my a is that 5.38. And I get a negative 10.0136. Why would it be a negative? It's going down. Any questions there? Okay, so there is one like that on the homework. I think it's like question 13-ish, but I could be wrong there. I don't remember exactly. So this one is just asking to find the derivative. So this is like question 29 or 30, something like that. So we're going to do a few of these. When I want you to do the derivative, we are just doing the definition, the limit as h approaches 0, f of a plus h. So that means you plug in a plus h in for all of these variables. So 2 times a plus h cubed plus a plus h minus f of a all over h. If you want to come out to the side and do the a plus h cubed. So if I FOIL the first two, we get a squared plus 2ah plus h squared. So then if I distribute, we get a cubed plus a squared h plus 2a squared h plus ah squared plus 2ah squared plus h cubed. Okay, so these problems, they're long because they require lots of algebra within them, but it's nothing you haven't done before. We've multiplied polynomials before. It's just a pain that you have to do it within these other problems. And this is probably a pretty good indicator that I'm not going to give you anything too crazy here. I'm not going to give you a t to the 5th power because I'm not going to make you multiply that out 5 times. A cube is about as high as we're going to go on these. distribute the 2 through there, we get 2a cubed plus 6a squared h plus 6ah squared plus 2h cubed. That's this. Then we had plus a plus h. Distribute this negative, so minus 2a cubed minus a. And at this point, you will always have things cancel. And what do you notice about everything that's left? You can take an h out. So we get 6a squared plus 6ah plus 2h squared plus 1. Which gives us 6a squared plus 1. Lots of fancy algebra here. Let's do one more and then we may stop for today and save the last couple for tomorrow. Did everybody get that one? Last one for today. Fx equals x to the negative 2. Okay, remember, a negative power just means 1 over that. So if we do the definition, the limit as h approaches 0, f of a plus h, so plug in an a plus h, minus f of a all over h. Bless you. You square that. What do we need here? Common denominator. So you are going to have to take this first one times a squared and the second one times a squared plus 2ah plus h squared. You do it on both the top and the bottom. Alright, so then if I put these together, we have one big fraction. What would you need to do with this negative? Distribute. Then a squared and negative a squared cancel, so we get negative 2ah minus h squared. Okay, on the bottom we just have h. That's like an h over 1, so if you flip and multiply, that's 1 over h. Does anybody see what we can do now? was just trying to get rid of the fraction within a fraction, so I just flipped and multiplied. Okay, on the top, right here, you could take out an h. And then those cancel. So now if you plug in a 0 for all of your h's, on top we just have a negative 2a. On the bottom I have a squared times a squared. So if you reduce, you get negative 2 over a to the third. So, these are requiring some nasty algebra. I'm aware of that. That's why we started this Friday. Still working on it today. We're still going to be working on it tomorrow. What I want to do now is give you guys some time to work on the homework. So, did I give you guys that assignment Friday? And it's also printed on your notes there. So, you've got time to work. If you want to work with a partner, that is fine.